So problem number 7 works almost exactly like the problem we had on our last exam. And the drawing's going to work the same too. We're going to actually have a police car. You know what? I'm going to be artistic. There's a little siren. Woo! And then I'm going to draw the speeder right here. Okay? And you know what? I'm not going to do that. I'm going to make the speeder orange. Okay? And there we go. So now, here's the thing. The cop car is at 0. Okay? The speeder, its initial position is 300. Okay? So I'm just going to label this as the speeder equations. And I'm going to label this as the, as the police. So 50. There we go. Okay, let's just move on. Now, the police car is moving at 30 meters per second. No, the police car has an initial speed of 0 meters per second. Okay? And it has an acceleration of 5 meters per second squared. And we don't know the time it catches up to the speeder. And let's get the speeder equations down. The speeder, it has an initial speed of 30 meters per second that never changes. So now, here's what we're going to do. We're going to actually write down equations for what we want is we want an equation. We want an equation for the speeder. We also want an equation for the police officer. And what I'm going to do is what I did in the last unit. So the speeder actually obeys the buggy lab rules. So it has an equation x equals v naught t plus x naught. And when we plug in its values, that's going to be x equals 30 times t plus 300. Okay? Now, the police car does not obey the buggy lab equation. It's accelerating. So its equation looks like x equals 1/2 at squared plus v naught t plus x naught. And you know what? I'm going to make one little change here. I'm going to put a little subscript here. I'm going to call this x subscript s for speeder. And I'm going to call this x subscript p for police car. So x for the police car ends up being 1/2 times 5 times t squared plus 0 plus 0. In other words, x of the police car is 2.5 t squared. X for the speeder is 30t plus 300. It's wonderful. So from the last unit, we know to set these equal, and what that means physically is that they meet up at the same place at the same time. So what I'm going to do is, I'm going to actually set these two things equal. So that's going to give me 2.5 t squared equals 30t plus 300. And now I've got my work cut out for me. So I'm going to write 2.5 t squared minus 30t plus 300 equals 0. And let me just do one thing here because I made a little mistake. This needs to be a minus sign there. So this is minus 300. Now, here's the deal. When you see an equation like this, unfortunately, we have very little choice. We're going to have to use the quadratic formula. Okay? So we're going to have t equals 30 plus or minus the square root of 900 minus 4 times 2.5 times negative 300 all over 5. So we end up getting a time equal to 18.49 seconds. Okay? There's a negative time, but we throw that out. Now here's what we do to get where they meet. We're going to take the XS equals 30 times 18.49 plus 300. That tells us they meet up at 855 meters. Okay. So that's the solution to the problem.